Welcome to my channel. World Scene News. Subscribe to my channel for news updates all around the world. For years, Huawei was expected to crumble under relentless US-led sanctions, its name synonymous with a company besieged by global suspicion and political pressure. Its global ambitions were reduced to a cautionary tale, a stark warning to others about the risks of challenging Western technological supremacy. The technological blockade was meant to be checkmate, severing Huawei's access to the world's most advanced semiconductors and cutting it off from critical supply chains. Yet, as 2025 closes, Huawei has re-emerged as the unlikely champion of China's quest for semiconductor independence, defying expectations and rewriting the rules of the game. The sanctions intended to cripple instead ignited a national crusade, a technological long march to build a sovereign chip industry from the ground up, uniting government, industry, and academia in a common cause. Huawei, with its deep engineering expertise and vast resources, was placed at the helm of this monumental effort, leading a new era of innovation and resilience. The company is now orchestrating a vertically integrated assault on the choke points that once guaranteed Western dominance, building everything from chip design to manufacturing and supply chain logistics in-house. Breakthroughs like the Mate 60 Pro smartphone, powered by a domestically produced advanced chip, signaled China's intent to compete at the very frontier of chip manufacturing, sending shockwaves through the global tech industry. The game has changed, and Huawei is holding a hand few believe possible, reshaping the future of technology and proving that adversity can spark a new era of ambition and innovation. To truly grasp the scale of Huawei's challenge, you first need to understand the heart of modern chipmaking: lithography. This is the intricate process of etching billions, sometimes even trillions, of tiny transistors onto a single silicon wafer, creating the brains behind every electronic device we use today. It's a marvel of precision engineering, where the tiniest details can make or break technological progress. For decades, chipmakers relied on deep ultraviolet, or DUV, light to carve out these microscopic circuits. But as the demand for faster, smaller, and more powerful chips grew, DUV's relatively broad wavelength became a fundamental barrier. The industry hit a wall. DUV simply couldn't etch features small enough for the next generation of chips. Enter extreme ultraviolet, or EUV, lithography, a revolutionary leap forward. EUV uses light with a wavelength of just 13.5 nanometers, which is so short it's closer to a soft X-ray than visible light. This allows chipmakers to draw impossibly fine patterns, unlocking new levels of performance and efficiency. With EUV, manufacturers can create the world's most advanced chips, powering everything from cutting-edge AI servers and supercomputers to the latest smartphones. These chips are the engines of innovation, enabling technologies that shape our daily lives and drive entire industries forward. But harnessing EUV is a feat bordering on science fiction. The process demands massive vacuum chambers to prevent contamination, the world's most powerful industrial lasers to generate the EUV light, and mirrors polished so perfectly that even a single atom out of place could ruin a chip. The engineering challenges are staggering, requiring collaboration across physics, chemistry, and materials science. Only one company on Earth, ASML in the Netherlands, has managed to master and commercialize this technology. Their expertise is unmatched, and their machines are the result of decades of relentless innovation. Each EUV machine is a technological marvel, costing over $150 million apiece. They are the crown jewels of the semiconductor industry, representing the pinnacle of human ingenuity and precision manufacturing. Possessing EUV technology is more than just a competitive advantage. It's the sole entry ticket to the frontier of chipmaking. Without it, companies are left behind, unable to produce the most advanced chips. Without access to EUV, you're effectively locked out of the future, unable to participate in the next wave of technological breakthroughs. ASML's monopoly has turned its machines into the ultimate geopolitical choke point, with global supply chains and national interests converging on this single company. The United States and its allies have used this leverage to enforce sweeping technological sanctions against China, restricting access to the most advanced chip-making tools. For China, breaking this monopoly isn't just a business goal, it's become a matter of national destiny, shaping the country's ambitions for technological independence and global leadership. The US led a global campaign to block China from acquiring ASML's EUV machines, forming a technological Great Wall of export controls and blacklists. The Dutch government, under US pressure, withheld export licenses, slamming the door on China's ambitions for advanced chips. For a time, this seemed to cement the global tech hierarchy. But as Huawei and its partners showed ingenuity, the sanctions widened, eventually restricting even advanced DUV machines from Japan and the Netherlands. The goal, not just block the frontier, but make even approaching it nearly impossible. The blockade expanded to chemicals, software, and every link in China's supply chain. The wall grew higher, but in doing so, it created the perfect conditions for a revolution born of desperation. China was forced to innovate or be left behind. Blocked from EUV, Chinese engineers led by Huawei and SMIC turned to DUV multi-patterning, a brute-force workaround. Instead of a single EUV pass, DUV multi-patterning requires multiple exposures, painstakingly building up intricate circuits layer by layer. It's complex, slow, and expensive, with lower yields and higher costs than EUV. But it works. By repeating exposures, engineers can approximate the density needed for advanced chips. The process is like building a house with hand tools instead of power tools. Despite its inefficiency, DUV multi-patterning was a strategic victory, proving the EUV blockade wasn't checkmate. It allowed China to produce advanced 5G and AI chips domestically. This stopgap bought China precious time to refine its processes and develop its own lithography tools. The world was forced to take notice. China's technical resilience had been underestimated. In late 2023, Huawei stunned the global tech community by unveiling the Mate 60 Pro, a flagship smartphone powered by the Kirin 9000S, a 7nm chip designed and manufactured entirely in China. This was a technological leap that few thought possible under the weight of strict US-led sanctions. The announcement sent shockwaves through both technology and policy circles worldwide. Experts and analysts were left scrambling to understand how Huawei had achieved what was widely considered impossible, defying years of export controls and trade restrictions. The Kirin 9000S was the first chip to emerge from China's mastery of DUV multi-patterning, a complex process that had only existed in theory for Chinese firms. Now, it was a production reality, demonstrating that China could innovate under pressure and adapt to technological barriers. For Huawei, this breakthrough wasn't just about short-term profits or market share. It was a bold statement about strategic sovereignty, signaling that China could chart its own course in advanced technology, independent of foreign suppliers. The Mate 60 Pro quickly became a symbol of national pride. Across China, crowds lined up to buy the phone, and it sold out almost instantly, sparking celebrations and a surge of patriotic enthusiasm. The timing of its launch, coinciding with a high-profile US official's visit to China, was no accident. It sent a clear and unmistakable message to the world. Efforts to contain China's technological rise were not working as intended. The phone's runaway success validated Huawei's risky, years-long strategy. It also galvanized China's entire semiconductor ecosystem, inspiring engineers, entrepreneurs, and policymakers to double down on innovation. Investment in chip research and manufacturing accelerated. The achievement attracted top talent from across the country, and solidified Huawei's leadership at the forefront of China's tech ambitions. The Mate 60 Pro was not the end of the story, but the beginning of a new chapter in the global chip war. It marked the start of China's offensive push to become a true leader in semiconductor technology. The world now had to reckon with a new reality, one where China was no longer just catching up, but actively shaping the future of technology on its own terms. While DUV multi-patterning kept China in the game, the real goal is mastering EUV technology itself. For years, a domestic EUV machine seemed a distant dream, but in late 2024, researchers at Harbin Institute of Technology announced a breakthrough, a stable EUV light source using laser-induced discharge plasma. Though still a prototype, it cracked the fundamental physics problem. Huawei has been deeply involved, investing in research and filing patents for EUV components. Alongside the light source, China is making progress on domestic DUV scanners, with new prototypes emerging from Huawei-linked affiliates. The strategy, perfect DUV first, then tackle EUV integration for high-volume manufacturing. The road is long, but the first hardest steps have been taken. China's EUV ambitions are no longer science fiction. None of this would be possible without massive state backing. Beijing has poured tens of billions into Huawei and its partners, treating chips as a matter of national security. Funding comes as grants, subsidies, loans, and contracts, allowing Huawei to invest in R&D and build a domestic supply chain. The government's Big Fund nurtures the entire ecosystem, from startups to established players. Huawei, through its Hubble technology arm, directs capital to fill key technological gaps. This state-led model lets China play a long game, prioritizing strategic goals over short-term profits. The result? A tightly coordinated national team with Huawei as captain. Making chips isn't just about hardware, it's about software too. The US cut off China's access to advanced electronic design automation, EDA, tools, aiming to halt chip design. Huawei responded by partnering with Chinese firms to develop domestic EDA tools, reaching the 14-nanometer node and above. Meanwhile, China is embracing RISC-V, an open-source processor architecture immune to Western controls. Tech giants like Huawei, Alibaba, and Tencent are building a sovereign technology stack. From RISC-V to domestic EDA to homegrown chips. The goal: full autonomy, immune to sanctions. China is building its own digital future, layer by layer. Huawei and China's progress is reshaping the global semiconductor landscape. The era of unchallenged Western dominance is ending, replaced by a parallel, state-driven Chinese ecosystem. This could split the world into two tech spheres, one Western-led, one China-centered. The road ahead is tough. China still faces huge engineering hurdles and global rivals are pushing ahead, but the direction is clear. The chip war is now a marathon, not a sprint. The world may see a tech decoupling, with countries forced to choose sides. Innovation may slow, but for China, autonomy is worth the cost. The attempt to sideline Huawei has created a fiercer, more resilient competitor. The chip war is far from over. It's entering a new, unpredictable phase.